Hi, good morning, good afternoon, good evening. Welcome to this Corelight webinar. Today, our topic is going to be New Age Network Detection, keeping pace with the evolution of tech infrastructure. So we have two panelists today. First and foremost, from Securosis, Mike Rothman, a president and analyst. Mike, do you want to talk about your background or anything about yourself?
Sure, Nick. Thank you. So I'm Mike Rothman. Pleasure to be here. I'm a 30 plus year security professional. I actually started my career as a plumber. So, being the network, not like literally a plumber, right? I call connectivity, right? Networking as kind of the plumbing of technology. So I started my career in wiring closets and messing around with thick nets. So I've been doing networking for quite a long time, been specializing in a lot of kind of cloud evolution over the last 4 or 5 years, or probably a little bit longer than that at this point. But really exciting to be able to chat with everybody today about one, some new research that we did. Partnered up with our pals at Corelight about new age network detection, but also really just to get a sense of how the disruption that we've seen in terms of cloud and SaaS and remote working and a lot of the different new attack types are really impacting how we have to think about network detection and response. So we're really excited to kind of start to talk a little bit and have a great conversation with Vijay on that as well.
Absolutely. And so we're also joined by my esteemed colleague, Vijay Nair. He is the Senior Director of Product Management here at Corelight. Vijay, would you like to say a few things about yourself?
Absolutely. Thanks, Nick. And hey, everybody, glad to join all of you on this webinar. I manage the cloud security portfolio here at Corelight. I've been here for a few years, and it's been kind of fascinating to see as more and more enterprises make their migration to cloud. What are some of the things that they're running into, and what are some of the challenges that they're facing, and what kind of visibility can they need to maintain a secure infrastructure? And that's something that we wanted to talk. Mike and I want to talk to you about in this webinar. And Mike, it was fascinating. I didn't realize you had a lot of the same background that I did. I was a network engineer for a long time too before I transitioned to security, and I am interesting to hear that. Funny that this is the first time I heard it.
Yeah, no, that's right. I mean, it was one of those things where, I was kind of the jack of all trades. And we needed somebody to, kind of take a look at network security on that front. And honestly, I've been trying to get out of this business ever since. And that's probably close to 25 years ago.
Good luck.
Unsuccessfully at that.
I thought you were going to say you were a plumber as well. So my name is Nick Hunter. I'm a technical marketing manager here at Corelight. I've been with Corelight for just about 9 months. Prior to that, I spent a long time doing technical enablement at Symantec, and also worked inside of the SOC as part of the RMSSP offering. So I spent about 7 years there. I started my career as a beta tester for a little known company called Bethesda Softworks. If you haven't heard of them, they were just sold this past year for $5 billion to Microsoft. So that was way back in the 80s. So with that, we're going to have a fantastic conversation. We do have a couple items on our agenda, specifically about, for the conversation, we're going to discuss some new approaches to network detection and security. We're going to then apply those approaches. How do you apply them? And to cloud-based resources. But we're really going to try and focus on covering the latest advances in security analytics and the advantages of an open data approach. So with that, it's the new age of network detection. How do you actually keep pace with the evolution of tech infrastructure today?
Yeah, I think a lot of the challenge that we have here gets to access, right? In the old days, right, Vijay and I were just joking about, kind of our background, our common background in terms of being, kind of network engineers and getting pulled into security. We always had access to the network. we could go down, again, into the wiring closet. We could tap the network. We could, set up a span port and get access to a lot of the telemetry and the traffic. But as we see and as we've seen a lot of this evolution, and that evolution is really driven across two vectors, right? One is, kind of this whole remote work thing that we've all had to deal with. I'm sitting here, kind of recording it from my basement desk. I'm sure Nick and Vidget are similarly in their home offices nowadays, because that's just kind of how we do things. But obviously, a network engineer, can't come into my basement, or I guess they could. It probably wouldn't work out very well, to check out my network to see, what's happening. So we don't have that visibility anymore. And then on the other side, we have all of our data dispersed all over the place between public cloud, software as a service environments, partner networks. And again, common to all those environments is a lack of traditional ability to tap into the network, to get access to the physical layer. And that really requires us to change our tactics, right? It really requires us to think quite a bit differently about how we're going to get access to the network environment, how and why and what our sensors need to look like over time, right? What is the right amount of telemetry that we can use? How do we leverage a lot of the capabilities that the cloud providers themselves are giving us? And ultimately, how can we leverage advantages on both storage and analytics to make sure that we're in a good position to detect a lot of the potentially nefarious activity that we see out there. So that's really the concept, and of new age network detection, and that's something that we wrote about in the paper that's actually here within the event, and I know you can get that through Corelight as well. But it really is kind of a treatise on how we need to evolve our network detection approach to ensure that again, we're ready for what's coming at us, because honestly, it's here. Right, we've been talking about it as this thing that's out there, but remote work is here, right? Cloud is here, SaaS is here, and that means that visibility, at least from a traditional network detection standpoint, is not here. So we really need to, kind of change our tactics in order to keep pace.
Yeah, that's actually spot on, and I feel like it's something that we've all sort of become acutely aware of, especially over the past few years, with the advent of the pandemic going on around us, that more and more people are moving away from sort of the traditional office and going remote. More and more workloads are moving to cloud. We've seen a lot of companies sort of accelerate their cloud migration because there aren't any boots on the ground to deploy things to the data center. And all of this just sort of accelerates, what Mike was talking about, which is a move in the right direction for where we want, the future of our network infrastructure to be, but also sort of lack of visibility from what traditionally enterprises are.
No, that's right. And I think that, kind of we start to think about different tools, right? Because that's always the easiest thing to do. It's like, oh, we have a new problem, so therefore we need a new set of tooling. And I don't necessarily think that's the case, right? For some things, yeah, I mean, you do need to have a different capability, but in a lot of cases, the stuff that we already were doing, can certainly bridge us, into this new world. And I don't know that any of this environment is truly mutually exclusive. Right? I mean, it's not like our corporate networks are going away. I mean, yeah, we're not there as much, but we still have a whole bunch of workloads that are sitting within data centers. We still have distribution centers, depending on your business, and smaller offices that we have to think about. So, and again, I think a lot of getting our arms around what this environment looks like isn't just about how are we going to get telemetry from these new environments. It's also how are we going to integrate that with what's happening in our existing environment as well, and make sure that, again, we're not positioning ourselves in a way where we're just getting blind spots, right? Where we just don't know what's happening in our environment. And when we don't know what's happening in a lot of cases, sooner or later, it's not going to be great. So we really want to, again, focus initially, at least on that visibility piece of it, which, again, starts to force us to think about, what our sensors are going to look like, where we're going to insert them, what is the most effective way to gather the telemetry, what kind of telemetry should I be gathering, right? Did you remember the state of the art was, full packets for a long time. Now, do we need full packets in all cases? Probably not, right? So again, I think what this does is it gives us an opportunity to take a step back and to really evaluate what makes sense for the use cases, right? What makes sense for the attack surface and what, kind of the threat actors that we're worried about, the adversaries that we have to deal with, what they're likely to do, again, to make sure that we're well positioned to be able to have the telemetry, that's collection, and analyze the telemetry to really, again, discern if we're under attack by some kind of malicious actor.
Mm-hmm.
Yeah, there's a concept that I've been talking about that I'm hearing more and more. It's called the reducing the adversarial's maneuverability space. So if you have a defensive maneuverability, and then you have an attacker's maneuverability. And by reducing, it's a lot easier when we were all in the office and everything was, inside the perimeter. But as the perimeter is expanded and you have a remote workforce, protecting each endpoint is right now how most organizations think about zero trust and solidifying that perimeter now, because it's that endpoint. Well, what happens when you get past the endpoint? What happens when that endpoint is compromised and the adversary is now in the network? That maneuverability advantage now goes to the attacker without that clear visibility and monitoring of the network and keeping it, a constant eye, a full record of everything and anything that happens on the network to reduce that network maneuverability space that the adversaries have.
Yeah, I think that's actually a very important point, in that, again, without kind of sufficient visibility over what's happening, and it kind of alludes to one of the, I don't want to call it a sin, right? Because it was something that, we just did because we didn't really have a lot of other options. But that's this idea of perimeter-centric network security, right? Or perimeter-centric security. We thought all the bad folks were out there, so we focused all of our efforts, right? All of our controls, all of our monitoring was really, focused on that perimeter, right? The DMZ and kind of resources that were directly accessible via the perimeter. And then at some point we realized that, that wasn't the, kind of most significant attack surface. I mean, sure it was, but we spent, certainly a lot of attacks are coming that way, but the path of least resistance tended to be to go after specific users, right? And then once they got a foothold and then persistence within the internal network, it really was about how am I going to, kind of pivot, how am I going to maneuver within the corporate network to go get at the resources that I'm trying to access. And if you weren't looking, right, and that's where a lot of our traditional or, kind of more modern network detection and response capabilities really have started to emerge. And that, kind of, again, if I'm not looking at the internal network, how can I be surprised when, kind of folks pivot and do recon and, generally just run roughshod over my environment. And again, I think that, we did want to kind of talk a bit about cloud here. But to me, it's a similar type of concept, right? In that if I'm not looking, it's really hard to find stuff. So, again, getting our arms around what that telemetry looks like, where and how we should be, gathering it, aggregating it, and ultimately analyzing it. Those are the key decisions to make as we start grappling with what this new age network detection environment looks like.
That's a great point. So, Vij, isn't the cloud inherently more secure? And what should are there things that SOCs and security operations teams can do, and those cloud security teams, if they don't have that same relationship with traditional security operations teams, how do they actually secure their environments and build out that maturity model in a cloud centric approach?
Yeah, this is a question that we run into all the time. Is, hey, you're moving to AWS or GCP or Azure, what have you. Isn't that inherently more secure? And I always sort of, try to look at this question in a couple of different angles, right? Like if you hop over to the next slide, there's a little graphic that shows sort of what the what the cloud providers call a shared responsibility model, right? Where the cloud providers are responsible for the security of the infrastructure, the underlying platform, but you, the enterprise, is still responsible for every workload, every application that's running on top of that platform, every piece of data that's existing on that platform, every access that you're making from that platform out to any other service, right? And you guys were talking about this sort of the traditional view of perimeter dissolving, which is absolutely true, because now you can access your cloud environment from anywhere in the world, and the only perimeter that you have are IAM accounts, right? Like any IAM accounts that gets compromised immediately gets a attacker access into your environment from anywhere in the world. So and even if you think about the shared responsibility model and how much focus the cloud providers put on the underlying infrastructure, it's still not 100% secure, right? Because if you think about some of the latest stuff that has come out, AWS had the breaking formation super glue vulnerabilities that they disclosed. Azure had ChaosDB and Azure Escape that got disclosed late last year. All of this points to the same fact that even though we kind of put our faith in the cloud providers to secure their infrastructure, it's that same old model of you want to trust them, right? They are inherently more secure, but you want to be able to verify it as well, right? You want all the tools in place to be able to monitor your environment so that you can verify that there isn't any malicious activity going on in your environment. There isn't an attacker sort of walking through in your environment. And that's kind of the bottom line of, in cloud security, what's different is the cloud is inherently more secure, but you still need a lot more visibility in the cloud environment to make sure that you can verify it.
Sure. I mean, trust but verify, right? We've been talking about that for, I don't know, 25 years or so, if not longer. You did mention a couple of interesting things there that I wanted to, highlight, Vijay, because it's pretty important. One is that, yes, you are somewhat dependent and constrained by the cloud services that you're going to use, right? You mentioned breaking formation as a recent vulnerability that was found within the AWS environment. That was actually an issue with their cloud formation environment, allowed you to take over or actually put in, kind of unauthorized commands via a cloud formation template. And that was something that was within the cloud provider's capability to actually fix. But what I really wanted to discern, we talked about shared responsibility model, but let's talk about accountability for a second. Right? There's no shared accountability model, right? Yes, AWS or Azure or GCP or Oracle or Alibaba or any whatever cloud hyperscaler you're using, they are going to have some responsibility from a security standpoint. They are going to have zero accountability for that, right? The customer is still accountable for what happens in the cloud environment, which again means shame on you if you're not looking, right? Shame on you if you're not doing what you can to ensure that you've got the ability to gather, aggregate, and analyze the telemetry that's coming off of those environments. Because although we do have capabilities, and I would certainly posit, I've been working with clients for the last 7-8 years, helping them architect more secure environments, right? More secure tech stacks in the cloud than they can do on-prem. If you screw it up, it's not great. Right? I mean, if you make mistakes from a configuration standpoint, if you, kind of miss or reconfigure, one of the networks, I mean, you can pretty much open up everything within your environment, to the outside world. So, and again, it's one of these things where if you do it right, it can be far more secure, right? Isolated by definition. If you don't, it could be, again, just catastrophic. And that's, again, reason why we've always focused on visibility as one of the key aspects of something that's important to do before you even start moving workloads into the cloud, to make sure that you've got the ability to figure out what's happening in your environment and be able to identify, potentially malicious activity. I mean, it's just absolutely critical.
And if I think about sort of how the folks that are moving to cloud, how they're evolving, it sort of harks back to how the on-prem world evolved, right, over the last 25 years. I mean, like you said, Mike, a lot of the focus used to be in the on-prem world on prevention before, a lot of folks came to the realization that prevention is not good enough. You need a robust detection mechanism and a team that focuses on that. And in some ways, the cloud is going through that same evolution, because if you look at a lot of the point products and tools out there today, CSPM and so on, a lot of them focus on basic prevention, right? Is something misconfigured? Are the policies right? Are the right policies in place? Do the right IAMs have the right sort of resource accesses and the least privileged resource access in my environment, etc. But these are all, as we know, prevention policies only, right? What as more sophisticated and risk-averse enterprises start moving to the cloud, they're coming to the realization that that is not going to be enough, right? They need a robust DFIR process and workflow in the cloud, very similar to what they have.
No, that's right. That's right.
That's a good point, Vijay. So what does a mature network detection stack look like? And either of you can take that one.
Vijay, why don't you start, and I'll lay in some commentary, since that's what I like.
Sure. So in my mind, a network detection. So first, to begin with, why network detection, right? Network detection is important in this view of the world because a view of the network in our mind represents something that is closest to the truth, something that cannot be retroactively modified, something that represents something that cannot be fiddled with, something that cannot be evaded, right? So that's why network detection, we always think of it as sort of the honest source of truth. A stack that focuses on network detection has several components that we think are important. One, it really has to be something that analyzes the network traffic and generates rich security-centric metadata, right? And I compare this with, when a lot of folks say network detection, they think NetFlow or VPC flow logs, right? And the challenge is in any of these cases, in with VPC flow logs, for instance, there is so little information available that it's not even close to being deep enough for what you need to understand about your environment, right? So the first thing in any network detection begins with being able to extract rich, security-centric, judgment-agnostic data that can be used for a wide variety of use cases. Two, and this is more of a Corelight philosophy, which we have derived from a lot of the security professionals out there, the advanced defensive teams out there, is that a stack that is based on data and not detection is extremely valuable, right? Because data is durable, data lasts forever. Whenever there are new vulnerabilities disclosed, whenever there are new threats found, you can always go back to the data that you have collected over time and figure out what kind of if any intrusion has happened in your environment. Data also has a lot more applications, right? You can, once you have rich, high-quality data, you can write a whole bunch of detections on top of that. And a lot more use cases can be enabled. Not only detection and investigation, but something very akin to active threat hunting can be enabled by rich, high-quality data. And finally, in my mind, the one thing that differentiates most security products out there, is who are the people developing these products, right? You obviously have vendor products that are developed by a small team of software engineers in the vendor land, but I put a lot of my faith not only in the DevOps world but also in the SecOps world on tools that are built on open source, right? Because one, it's openly available. You're not tied to any one particular vendor or the other. But two, and most importantly, there is such a huge community of folks that are developing on top of these tools that you get sort of the hive mind effect, right? You get the you get sort of the collective knowledge of an extremely large number of defenders from all these sophisticated organizations that are developing and contributing to the open source, which is far more effective than a few teams of engineers developing on it. So that in my mind is what really defines what a robust and mature network is.
Yeah, I mean, the thing that I would kind of add to that, Vijay, is really the idea of extensibility from a number of different perspectives, right? We don't exactly know what, kind of the next data source is going to be, application source of attack. I mean, if there's one thing that we could say, being multi-decade folks in this business, is that I didn't see that one coming, right? For almost all the different, major issues that we found, like, oh, didn't see that one coming. I guess, I don't know, maybe if you had a crystal ball, you should be, kind of speculating in the stock market as opposed to doing network security. But we don't know. So we want to make sure that, again, that data model is going to be extensible to be able to support, whatever additional types of telemetry we're going to need to consider over time. And I would also, talk about extensibility from the standpoint of the analytics that we're going to do on top of that data, right? Love the fact we want data, as much data as is practical. Obviously, we have, kind of storage and economic realities that we can't keep everything ad infinitum. Obviously, the transition in using predominantly metadata as opposed to, full packet captures does change that, calculus a bit. But all the same, I mean, we are going to have to, make some choices at some point about, how much data we have there. But what I want to make sure is that I've got a sufficient data, kind of repository or data lake to be able to do, some pretty cool analytics on it, and really to identify patterns that I'm not sure I knew what I was looking for, right? The first wave of a lot of intrusion detection back in the day were attacks that we knew were coming for us. Right now, we don't know what those attacks are. So we want to make sure that, you have enough and a sufficient, pool of data to be able to start doing some of that pattern matching, pattern analysis, and analytics capability to identify those situations that you didn't know what to look for, right? The unknown unknowns, and give us the ability to discern those patterns and be able to evolve and change, because again, the attackers are evolving and changing on an ongoing basis. So we really want to make sure that, regardless of the stack that you put in place, it's going to be able to grow and evolve from both a collection, normalization, aggregation, and ultimately analytics perspective. Because if there's one thing I know, it's that I don't know what, kind of the next set of attacks are going to be.
Mm-hmm. Yeah, very well said, Mike.
So what kind of detection or investigation use cases does network detection in the cloud, what does that look like, Vijay?
So these were really sort of, we worked with some of our early adopter customers that deployed network detection stack in their cloud environment. And we kind of sat down and interviewed them, and this is kind of what we got from them, right? So these are not sort of use cases that we made up in a PowerPoint presentation. This is really what some of our customers detected in their environment. So for example, DGA, as most folks know, is a pretty common attack vector in on-prem and cloud networks. And it's usually used, for those who don't know DGA, it's a common technique to evade sinkholing in an EC2. So you keep changing the domain that your C2 reaches out to using a domain generator. So every day it's reaching out to a new domain, and it's impossible to sinkhole all that traffic. In the what one of our cloud customers detected was that they had a malware, using, reaching out to their C2 using DGA in their environment. And what they realized was that, the detections that they had in place, like things like, the native cloud threat detections that they had in place were not robust enough to detect it and alert on it. And infrequently when it did, it had, there was absolutely no context to figure out where this DGA was coming from and what to look for in the logs, right? So they pretty much ended up sort of completely turning off or ignoring that alerting in their native mechanism. But what they realized and what they were able to take advantage of was, in the Corelight logs, you can look at in a typical DNS log, you can look at the length of the query, right? You can look at what the query is, what the response is, what the length of the query is, what sort of the lexical distances between the queries, and you can pretty reasonably figure out whether this is a legitimate domain versus a DGA. And in addition to that, we have added a specific detection for DGA that essentially runs through a large number of DGA algorithms and figures out whether some of the domains that we are noticing are connected to DGA or not. So with a combination of these, they were able to with a pretty high degree of specificity, able to detect DGAs in their environment. And I can go through a couple of more use cases. Just
well, let me add, because I want to prove a point here, Vijit. DGAs have obviously changed rather dramatically since every 6 months or so, 12 months, maybe even more often. Can you just explain a little bit about kind of how your approaches have evolved with, kind of these DGA, kind of algorithmic based ways to, kind of isolate and identify command and control?
Yeah, so there are, what we do is, as much as I can talk about on this call, right? There's some proprietary stuff that we do, but the most generic thing that we do is there are a list of pretty commonly known tools that are used to generate DGAs. And essentially, we run these sort of on a periodic basis and figure out, what are the domains that we expect on, for that specific duration, right? For that specific day. In addition to that, there are some other techniques that we could use, and a lot of our customers use by looking at the raw logs themselves. Is you can write your own analytics for this, for example, which can look at how many subdomains are in this query, right? What are these sort of real? Are these commonly known domains, or are these not very common? When were some of these domains registered? Right? We can use a combination of these to figure out what is the probability that this is a weird domain versus something that is listed.
No, that's exactly right. And the point I wanted to make, which you proved, I think wonderfully, is this idea that the tactics are going to constantly evolve, and making sure that you've got the ability to, again, evolve with, kind of make sure that your detection capabilities can evolve with, kind of the attackers as well, is absolutely critical. So I think that's common among all the different use cases that you kind of outlined here, Vijit, is that, it's not just about collecting the data, although without the data, you can't do much. It's really about making sure that you've got, kind of the ability to, match the analytics to what the requirement is over time.
So what are, we talked about, I think you brought it up earlier, Mike, about IDSs and, that traditional security stack that organizations have always relied upon, which is, endpoint protection, IDS monitoring, firewalls, perimeter defenses. Now with the shift to the cloud and that whole perimeter being gone, you've got cloud infrastructures. You've kind of, they're not exactly reinventing the wheel in the cloud. What are some of the newer types of security stacks and techniques that are being leveraged and can actually, we talked a little bit about AI and ML. What other tools, should others be looking at?
Yeah, sure. So obviously there's the whole visibility thing of, kind of configuration. So there's a tool set called Cloud Security Posture Management. So that's something you want to, look at from the standpoint of, just making sure you have your cloud environment configured correctly. But, really, I think the biggest departure in terms of understanding how to best leverage the cloud is that it tends not to be a thing, right? It's what it is thinking differently about how you architect your environments in the cloud. So it's really using architecture as a security control. You can build tech stacks that are isolated by definition. So it makes it very difficult to, move between the different tiers of the application stack because of the way you've configured the network, right? And you could put in place fairly sophisticated transit networking capabilities to really mediate, but more importantly, to monitor and protect the traffic that goes in between a lot of your different, cloud accounts or cloud subscriptions. So you can really use architecture as a means to better isolate the data and the code that's running these environments. But again, back to that important point of trust but verify, in that we want to take advantage of the fact that the cloud providers can give us reasonable telemetry, certainly from a logging standpoint, flow data, and depending on the cloud provider, you could even get, kind of packet streams that would allow you to derive metadata. So it's a combination of, taking advantage of the architectural advantages that you can use by moving to a cloud native type environment, but it's also taking advantages of the capabilities that your cloud provider are bringing to the table in terms of their native services, and then maybe some third party on top of that, and really give you the base of data to allow you to do some type of security analytics that, again, I believe should extend to your internal networks as well, because again, depending on where, kind of the keys to your kingdom are, your most sensitive data, some folks may try to, get in through the cloud to pivot, back and move laterally, onto your on-prem networks. And that's something we have to worry about as well.
That's really good, because what you just talked about is, the concept of microsegmentation inside those cloud architectures. And Vijay, how does Corelight address microsegmentation and monitor the gaps that between the different segments, both from the segment to segment, but then out to the outside world and back?
Yeah, I mean, this is sort of a perfect segue into the next use case, if you don't mind, Nick, which I promise while Mike was talking about that, I was like, man, and this is one where, Mike, like you were talking about, right? You can segment out some of your subnets in your AWS environment so that there's only one public subnet. Everything else is sort of isolated, and you could create, all these sort of very isolated segments, but really in the cloud, even in on-prem, I would say, but arguably most definitely in the cloud, there is no such thing as a completely isolated subnet, right? This particular use case is an example where you might have a subnet that is completely isolated from the internet, no way for it to reach out. But guess what? Every service that is running in that subnet, if it needs to reach out and talk to some other service, it needs to access DNS. And once you have access over to DNS, there are ways that attackers could use a DNS tunnel in your access to DNS. They could create a DNS tunnel to actually start exfiltrating data, right? So they're not using your sort of standard internet channel or your standard connection through the internet gateway to get the data out. But every time you connect over to DNS, they'll set up a channel that goes through your DNS server, and they will get your protected data out from your environment. So this is goes back to that same point of, can you have an isolated subnet that is not accessing DNS, that is not accessing any other AWS service? And I think that's almost impossible, right? So then it comes down to, even if you have something that is completely segmented out, isolated out, what kind of monitoring and what kind of visibility do you need in those environments to be able to detect when some of these activities are going on?
Mike or Vijay, do you have any closing statements you want to make, or?
Sure. And again, I mean, I think that we covered a whole mess of stuff today, but if there's, really one or two main takeaways that I think are really important to understand the whole concept of new age network detection, it really is driven by the data, but having, kind of the extensibility of, both collection and analytics over time. Because again, if there's one thing that we've seen historically is that we don't know what's coming next, and we want to make sure that we've got, kind of the ability to collect the appropriate telemetry and analyze that to identify malicious actors in our environment. And the network, last time I checked, right, kind of we still plugged into things, whether it's virtual, right, over wireless connections, but we're still using some type of network connectivity to access the things that we're trying to get to. And that means network detection is always going to be a thing, right? It's always going to be an important source of telemetry to identify malicious activity, and we really need to treat it as such.
Yeah, and the only thing I'd add to that is we are sort of at the start of the journey of what it means to get sort of pervasive visibility into cloud environments and how to leverage it for the benefit of security teams. So we've only started to scratch the surface of what is necessary and what is possible in these environments. As more cloud providers start providing hooks and access into these environments, for example, getting access to raw network traffic and being able to analyze the network traffic, and a lot more, right? I think we'll see this space evolving pretty well. But great to be on with you, Mike, and thanks, Nick, for walking us through this webinar.
Yes, thank you, Mike, and thank you, Vijay, for your time today, and thank you specifically to everybody that's joined us. I think this was a fantastic session. If you'd like to learn more about Corelight, visit our website, www.corelight.com. And with that, thank you again, everyone, and have a great day.